Nos da mucho gusto tenerlos aquí y más gusto tener al doctor Chakraborty. En esta ocasión me ha pedido que él, dentro de su presentación, diga un poquito acerca de sus antecedentes y de los títulos que él tiene. Por lo tanto, no voy a profundizar en eso. Solamente les quiero decir, de verdad es un honor tener a una persona con esta preparación y con este conocimiento del tema. Así que pues aprovechemos lo más posible, siéntanse con total libertad. Él es bastante informal y quiere pues que todos ustedes se sientan bien. Por lo tanto, pues no me queda más que dejarle la palabra al doctor Chakraborty. Muchas gracias. Welcome.
Thank you, thank you, thank you. Gracias, gracias. I'm delighted to be here. I know some of the faces. Some of you have been in my workshop, and I'm happy to see some of you come back, so you're not worried that you still came back. This is, you know, I'm a marketer, and what marketing is all about is customers. Okay, so customers, we like customers to come back. The fact that some of you have come back tells me that it's a good thing. It's a good thing. I am really happy to be here. I'm delighted and honored to be here at UPAEP talking about analytics. Analytics is something that I am extremely passionate about. Okay, in life, you got to be passionate about something. I am very passionate about analytics. So I might get excited. I might speak a little faster. Please, it's okay to slow me down if I become too fast. Okay, but what I thought I would do is tell you some stories. But before I get there, let me give you my background. And this isn't. Many of you know me because you have been through my workshop. Some of you don't. So please bear with me as I give you a little bit of my background so you understand where I come from. Okay? First of all, I want you to understand this. Okay? This is a very important thing that I want you to understand. It makes no difference in your life where you came from. I'll tell you my story. I did not have electricity until my 8th grade. I'm born and brought up in a refugee colony. That's where I come from. Okay? It's okay. It's okay. But there is one thing that you have to have. In fact, two things. I talk about this all the time. There are two things in life you have to be successful. Okay? One is your curiosity, the ability to ask questions. You have to have that. And the second, you have to have ability. Ability is what you pick up through education. Curiosity is something that you develop from your childhood. That's something, if you have those two in life, it doesn't matter where you come from. Look at me. I tell you this story because I'm born and brought up in a refugee colony in India. My parents my ancestral home was in Bangladesh during the partition time. My parents they had to move, and so we were in a refugee colony. Didn't have electricity. Didn't matter. Didn't matter because what my parents instilled in me is the love for education. Education is your pathway to everything else that you want to do in life. That's something that you have to have. That's something that passion, if you have that, it'll go a long way. So my background, so I started as a mechanical engineer. Why mechanical? I don't know. Engineering is a good field, all right? I mean, it teaches you problem solving. That's what, do I remember anything about mechanical engineering? Heck no. Was I a good student? Absolutely. When I was in class, sometime I was not in class. I'm sure you are not in class sometime. But the truth is that taught me how to think logically, how to do problem solving. That's what engineering training is. Okay? I've worked as an engineer for a company called Union Carbide. It's an American company. For a couple of years I worked there, and I realized that what's happening is all my friends who were engineers, they became marketers, and they're earning more money and having more fun, and I'm sitting in a factory and doing this thing called maintenance engineering. So why? That doesn't make any sense. I need to have some fun. So I switched my line. So I did my MBA, and I became a marketer. So I had some fun. Marketing is fun. Business is fun. Okay? You get to travel, you get to make more money, and you also get to solve business problems, which is different than engineering problems. Nothing wrong with engineering, but engineering is a little bit tight. They don't always have that much fun as business people have, okay? But, so I worked for about 4 years again, and then I came to United States. I came to University of Iowa. I did my PhD in marketing, and then I fell in love with statistics. So I started taking statistics courses and landed up getting a degree in master's in statistics. So in other words, I had no clue what I was doing in my life. Engineer, marketer, statisticians, and a PhD scientist. What has that got to do with analytics? It has everything to do with analytics. Every one of those degrees taught me something that I can apply in the world of analytics. To me, analytics is nothing but problem solving. Using any data, tool, technology that you have, the ability to solve the problem, ability to pull in data, ability to analyze the data, ability to relate that data back to the problem, ability to communicate that back to the business world, and ability to go out and research when you don't know the answer, to find the answer. To find the answer. To me, that's what analytics is. Now, here is what we are going to do. I'm going to give you a sort of a very high-level overview of what I look at in the current status of analytics in the US. Okay? It's primarily US focused, the examples that I'm going to use. What's the current status, where we started, where we are today, what are some of the big challenges? This is nothing to do with a particular industry, but some of the big challenges that's across the board we face in trying to do analytics correctly. Okay? Give you a sense of that. Then, one of the reasons why I'm here is to explore the possibility of setting up some programs with UPAEP. So I'm going to talk about how our program developed over time, and then maybe perhaps down the road we might have some program with UPAEP as a joint venture that might work out, depending on. But for that to happen, you have to understand what our program is and what we do. So I'll talk about our journey in developing the analytics and data science program. And I call it a journey because you will see it's been a long stretch of years over which we have developed program. Not 1 year, not 5 years, not 10 years, more than 15 years. You'll see it in a minute, okay? And then because I'm a professor, no talk can be complete without giving you some of my favorite books. So I'll give you some. You don't have to buy any of them. You don't have to read any one of them. But if you want, I'll give you some of my favorite books on analytics. All right? Okay, so let's get started. I'm going to tell you this story. I don't know if you know this story or not. It's a famous story, and it's a true story. Target is a big department store, like Walmart. Okay? It's a very big department store in the US. And this is a real story. There's a link to this story that you can find. How Target figured out a teenage girl was pregnant before her father did. How Target figured out a teenage girl was pregnant before her father did. So what happened is the story goes like this, and it's a true story. So father of a teenage daughter walked into the Target store and starts yelling at the manager, saying, "Why are you guys sending to my household all this advertisement for baby stuff targeted towards my kid? She's only 16 years old. Why are you doing this?" And the manager says, "I'm very sorry, I don't know." Because oftentimes these kind of promotional things are not handled from the local store. It's handled from the corporate office. Target's corporate office is in Minneapolis, Minnesota. So that's where they send all of these flyers, the printed flyers that comes to your house. So the manager said, I really don't know. I'm very, very sorry this has happened. I'll talk to my corporate office. We'll stop this mailing to you, and we're very sorry, apologize. The father went back, and 3 days later, he came back, and he apologized to the manager, saying, I'm sorry, I yelled at you, but I found out my daughter is in her trimester, the 3rd trimester. What happened? Well, what happened is, some of my students actually work for Target in their data science department. So what happened is somebody in Target's corporate office in data science, they started asking the question, hey, is it possible, we have all this data on all these people, is it possible that we could figure out, are there certain combinations of products, stuff that women tend to buy when they're in the 2nd trimester of their pregnancy, more than what they would normally buy? What they found out, it's a combination of about 60, 70 different products. Some of them are like unscented body lotion or cotton wool and things of that, things that normally people will buy, but when they're in their 2nd trimester, they started buying much more than normal. So what happened is they created a model. They created an index saying when we find that a particular household is buying more of this than what is expected, chances are somebody in that household is pregnant. And so we will target them, we'll send them mailing by saying, hey, maybe you should want to buy a baby cot, maybe you want to buy a baby bag, and maybe you want to stock up on the diapers that you're going to be needing soon. It's a scary thought, right? I mean, before you know it, that a store has figured this out. But in order for that to happen, there are 2 things that has to happen. One is somebody has to ask the question. This doesn't happen automatically. None of these happens automatically. So I go back to what I said. If you don't have curiosity, nothing else matters at that point in time, because somebody has to ask the question. The program doesn't find these things. Once you start asking questions, then you start pulling data, then you start analyzing it, then you start figuring out, okay, maybe there is some combination that really is different. That's the story behind Target. Now, you might argue with me and say, but Professor Chakraborty, this is not fair. This is privacy, invasion of privacy. Guess what? You don't have any privacy, I'm sorry. It's your purchase data. You have given us the right. When you own these cards, you know the loyalty card? Why do the companies give you a loyalty card? Because they want to track your purchases. You have given it away when you have taken that loyalty card. Even if you haven't given it away there, you have given it away through a credit card. Every one of this is being tracked. Every one of this is being, so yeah, I mean, data is available. Now, we can argue what should be the rules and the regulation. That's a different story. And I do understand there needs to be rules and compliances and ethical use of the data and all of those. But the truth is, most of us have given our data away. Given our data away for something like a free coupon, or on your mobile, a free app. And you check this box that nobody ever reads. I'm sure you never read, which is, I agree. I agree, and then you have given me all the ability to track you. But anyway, so you'll have a copy of these slides, and it's okay to send these slides out so you can actually go back and read the story if you want to. I'm going to show you a picture. Anybody knows what this fish is? This is a fish. Anybody would like to take a guess? Most people, when I show them this fish, they say, oh, this must be the piranha. It's not piranha. It's called Patagonian toothfish. The name is Patagonian toothfish. Okay? Why am I showing you a picture of a fish? Well, think about it. If I'm in a restaurant, and you go to the restaurant, and I try to sell you for $40 US a fish that is called a Patagonian toothfish, would you buy it for $40, a fish steak? $40 US? No. But when I call it Chilean sea bass, you will. That's what it is. Patagonian toothfish is the real name for Chilean sea bass. What's in a name? The name matters. Why am I saying this is because today, if you deal with analytics, you'll see all of these names. All of these names. business analytics, data analytics, advanced analytics, data science, marketing analytics, web analytics, human resources analytics, financial analytics, healthcare analytics, you name it, you're going to find many of these names. So I have a question. What's in a name? The name does matter. The problem that we solve in the business analytics world, it's something we have been doing for a long time. It's nothing new. Using data, tools, and technology to solve a business problem is nothing new. Nothing new. What has happened is the scope of the data. The amount and the scope of the data has gone up. The technological advancement has made that the algorithms have become much more sophisticated. We have a lot more data available. We have a lot more complicated business world where things are interconnected that needs to be modeled correctly. But the fundamental principle remains the same, which is ask the question. Ask the question, start with the question, and then go pull data, use whatever tools and technologies out there to solve that problem. These are just context. We come up with different names, and we have to. You know why? I'll tell you why, okay? The reason is, it's called money, honey. Because if I call it the same thing, how many books can I sell? If I call it statistical analysis, I'll sell only one book. Okay? But if I call it today descriptive, tomorrow predictive, day after tomorrow prescriptive, then after that marketing, and then HR, yeah, I'll sell more books. Sure. Sure it is. No, I'm making fun of this. There are some differences in context. What kind of problem are we handling? Are we handling a marketing problem? Are we handling a human resource problem? Are we handling a sports problem? Are we handling a healthcare problem? Are we doing process engineering analytics, which would be operation research type of problem? Or manufacturing, where we are looking at manufacturing analytics, which is looking at process and variability in the process and trying to figure out how well to use these tools and technologies to control that process. Those are context. Those simply change the context, but the fundamental problem still remains the same, which is solving a problem. So just very quickly in terms of the progression with respect to analytics, and many of you were not born at that point in time, but for those of us who have been around, we started talking about decision support system in 1970s. And by the way, every time you hear that machine learning is new, I want you to understand we started teaching machine learning and talking about machine learning in 1970s. So don't let somebody fool you by saying machine learning is something which has just started 5 years ago. Heck no. They don't know what they're talking about. They don't read. That's the problem. If you go read, you will find machine learning started in 1970s. So 70s was decision support system. Then we went to this thing called enterprise executive information system. Then we went to business intelligence. That's the era of. Then we came to analytics. Now we are talking about big data, data analytics, data science. I'm sure next decade it'll be a different name. And there are all those little names. But the way I look at it is in a very simplistic way. Okay? Because I live in the world of business, everything I do has to relate to the business world. Okay? There are two dimensions on this graph. One is called the competitive advantage. Competitive advantage means, as a business, what advantage do I have over my competitors? Okay, that's competitive advantage. And the second is the degree of intelligence. How much? How much is the intelligence I'm getting out of the data? Okay? In this graph, and you're looking at a path. This path, raw data and cleaning of data, this is something what we start with. This is where everybody has, and this is a low intelligence and a low competitive advantage. Okay? And then we start moving up this path, and you got to figure out where you are in this path in terms of your company that you work for, or you may be going to work for. We start with the next generation of this is what we call ad hoc reporting, creating reporting on the fly, query and a drill down. That is online analytical processing, OLAP, that I'm sure you heard the term. Alerts, we're creating automatic alerts. These are all what we call part of descriptive analytics. As you moved up this line, what happened is the intelligence gets better than what's available in the raw data, and you are also generating some degree of competitive advantage. Then, when you start moving up even more, you go to the part of doing statistical analysis of this data, making forecast, and predicting what will happen next. That's the part of what we call is predictive analytics. Okay, that's what predictive analytics is. So, and as you move up to predictive analytics, from descriptive analytics, your ability to gather more intelligence goes up, your advantage goes up. But that's not the end goal. The end goal is at the very end, what we call is prescriptive analytics, which is an optimization. So it's not just so descriptive analytics talk about sort of looking back, what has happened, okay? This predictive analytics asks the question, why is this happening? What might happen in the future? And prescriptive analytics, the optimization is, what is the best thing that could happen? If I have the power to pull some levers and I can make some changes, what is the best outcome that I can get for my company? That is what prescriptive analytics is. That is what optimization is. Okay? So in the business world, so again, I've said I'm deeply rooted in the business world. The way we look at analytics, the analytics is a sort of a 5-phase process. Okay, the first part of this process is what we call the internal process optimization. The internal process optimization is monitoring what's happening in the business, looking at data to figure out the insights, what's happening, and internalizing the optimization of the business itself. This is where most of the companies are, okay? But the true part of in terms of what might happen if we can do analytics correctly, and this is where all of the digital companies are. This is the world of digital world of Amazon and Google and Facebook and everybody else. This is the world where most of the real world companies are. Okay. This is the part of going externally, monetizing that data that we have from customer and make money. There's nothing wrong in making money, okay? Please understand, it's okay to make money, all right? The point is, when you do business optimization, you are looking internally. When you are looking externally, you are saying, okay, can I use the data and figure out a way to make a business model that didn't exist before? You think of Amazon. You know Amazon is a seller of books and goods. You know where they make their money from? Amazon Web Services. A hosting service for data and storage and software. That's where they make most of their money from. That has nothing to do with what they started with. That idea of Amazon Web Services came in because someday Jeff Bezos, the richest man in the world, figured out that I've got all this data. People are storing all this data. Why not offer a data platform? We have built such a big infrastructure. Why not rent it out? That's the beginning of Amazon Web Service. That's the monetization part. That's the part where you are taking, not just looking internally within the business, but stepping outside and say, what can I do with it? What can I do with it? How can I make money out of this? And again, I know sometimes you might get scared when I say things like this, making money. But making money is okay. You know, life runs. I mean, you don't have money, life is problematic, all right? It's okay. I do want you to understand this, okay? The data is a very unusual currency. And if you're going to work in the analytics area, I need you to understand this. You know, when you have a dollar or a peso, you can use it only once. Because once you have given that to me, I own it. You can't use it again. But data is a beautiful thing. It is one of those that can be used over and over and over again. Once you have given me the permission to track you, once you have given me the permission to figure out what you buy, where you go, what you do, that piece of information I can use in multiple times and make money multiple times out of it. It's a beautiful currency. In the world of economics, we talk about it's a multiplier effect. Data has a multiplier effect. It multiplies in terms of what we can do with it. To give you an example, let's say you go to the store and you provide some data by buying some materials that you buy at the store, some goods and services, okay? one of the first things we can do is look at what you buy. Look into your basket. We call it market basket analysis. Look into your basket and figure out what kind of products you tend to buy together. And then map it back to your characteristics, your demographics, your background, where you live, what you have purchased in the past, how much money do you make, what's your gender. We use those to figure out what I might be able to promote to you so you come back and buy more. That's the first point we have used the data. Okay? One of the business cases we worked on, we found that by using this data, we can raise profitability by 2.5%. The same piece of data, we're going to bring it back to marketing. So this was for sales, promotion, all right? We'll bring it back to marketing by saying, oh, I see, Ingrid is a very good customer. Ingrid buys lots of high dollar stuff from us, and I make a lot of money. I like her. I like her. Can I find more of her? Can I find her characteristics? What does she look like? What's her age? What's her income? Where does she live? Who does she talk to on the social media? Maybe I can find her Facebook friends, and maybe I can get those people to come to my store. Can you imagine how this thing works? This is nothing to do with sales promotion. This is to find customer acquisition. We have a name for this. We call it look-alike modeling. Look-alike modeling. We find others who look like Ingrid, and then we go after them because we make money out of them. So for this company, that raised their profit by about 2%. The same piece of data. The same piece of data that we got from her, we would be using for customer retention. That's a different kind of modeling. It's called churn modeling. We have customers who come to our stores, they keep coming for some time, and then they don't come back again. So the question is, can we figure out before you quit coming to my store? Because once you quit coming, chances are you have already developed a loyalty towards another store. So before you quit coming to my store, can I figure out that you are likely to quit? Because if I do, then I am going to do some special targeting and special promotion to you to keep you back in the store, to make you come back. That's called retention modeling or churn modeling. Yes, part of analytics, but understand that that's being used in a different way. We might do call center. What we'll do is we'll pass on your information saying, hey, Dr. Claudia is about to drop off. She is, last 2 months she didn't make any purchase, and based on her profile, we figured out that she is not likely to come back if we don't make her come to the store immediately. Give her a call. We'll have the call center people call you, okay? But. And then last, that's a different, same piece of, all of this is happening based on this data that we collected. And then based on what you buy and what you don't buy, we might actually be able to figure out some new product. That is the advantage of data. The reason why you need to understand analytics is because this is what analytics is. The data is available. The point is, do you have it in you to ask the question? To ask the question how to use that data. That's beautiful when you ask those questions. That's what analytics is, in my opinion. So just again to give you a sense of this, where did analytics started and where we are today? So analytics started in the world of operations, marketing, and finance. Those are the 3 areas where analytics started. Okay? Almost all analytics applications that we look at in the beginning were in those areas: operations, marketing, and finance. Okay? In the operation, it started by forecasting demand. One of the first things we have to do for inventory control in operation is we have to forecast demand using time series models and forecasting model. So that's where that started. From the marketing world, we started doing this for buyer behavior, predicting what you are going to buy. Oh yes, we know what you're going to buy. We are almost 90–95% sure, looking at your past purchases, figuring out what you're going to buy. I just don't know when. The biggest problem in marketing is figuring out when you are ready to buy, not what you are going to buy. We know what you're going to buy based on your life cycle, based on your history. The when is the problem. The buyer behavior, that's the marketing models. And on the finance side, if you're interested in that, is the risk management. It's a huge area, the risk management, the risk analytics. And so that's where it started. But today, it's being used everywhere. You're interested in human resources? We have human resource analytics that predicts whether an employee is going to stay with us or going to leave. IT, we predict failure. We predict when the system is going to fail. That's a failure rate model. R&D, which R&D investment is going to be successful? Service, which customer is more likely to call for service? Which one of these will result in first call resolution? Which will not? Figuring all this out is asking questions and pulling data and answering questions based on those data, using appropriate modeling and tools. Procurement, absolutely. Supply chain analytics is a big thing. Accounting has become huge today. Fraud analytics. Again, understand the name. Remember that story of the Patagonian toothfish? What's in a name? We don't call it accounting. We call it fraud analytics, because it's a beautiful name. It's the Patagonian toothfish and the Chilean sea bass problem. Okay? That's what it is. So many more like this. Just like the analytics has progressed over time, so has models. It is no longer your father's regression model anymore. Regression is the tool that we grew up with. All of us at some point in our life has understood this model of regression. But today, there are so many models, frankly, it makes my head spin. Okay? So we have decision trees, neural net, random forest, support vector, gradient boosting, rule induction, deep learning, CNN, RNN, unobserved component model. Oh my gosh, this is just a small glimpse of what the modeling and the tools that are available today. Any problem that you want to solve today, the models are available. What you need to understand is, can you ask the right question? And then can you figure out which one of these models is the correct model? And then can you apply it correctly and explain back to the business why that is the right solution? That is the fundamental challenge. It's not the algorithm. It's never the model. It's never the model. Never, never. It's figuring out what works and being able to explain it back as to why it worked. That's where education comes in. I'm going to switch gears, so that's sort of giving you a state of where we are in terms of analytics, where we started and where we are now today. I'm going to talk about some of the big challenges that we see in the world of analytics. What are some of the key challenges? I don't mean this, in a bad way. I know, it's nothing to do with religion, but this is a statement that I really believe in. This statement is not by me. It's by a gentleman named Charles Deming, D-E-M-I-N-G. If you don't know who Charles Deming is, you don't know anything about total quality management that started in end of 1970s when Japanese companies took over the entire automobile industry in the United States. And you know why? Because Charles Deming, who used to work in Detroit, he kept saying that we got to look at the data, we got to look at the data. And the American companies said, no, what the heck you talk about? We don't have to look at the data. We know what we're doing. So he left. He went to Toyota. And he taught them how to do total quality management, which is the beginning part of doing analytics. That's his quote. In God I trust. Everybody else, bring data to the table. When you make a decision, I want to see what the data underlying that decision. That's what that really means. Don't tell me, trust me. When you tell trust me, I'll say, what's the data? Where is the data, that trust me part? Only God that we trust. So here are the 4 big pieces of problems that we have in doing analytics correctly in the organizations today. One is what we call data integration, management, and access. And I'm going to talk about the V's. I'm going to talk about the V's of data, and you'll see it in a minute, okay? And there's also this issue between, there's a constant struggle going on in the US world between business intelligence versus analytics, because there is commonality between the two and there is differences between the two. So the data environment creates some degree of problem. The traditional BI environment of the data is not necessarily the right environment of the data for doing analytics and data science. So I'm going to give you a sense of what that is. Then definitely software is a challenge. It continues to be a challenge. There are plenty of different softwares, but enterprise level software continues to be challenged. The good news for you, the students in this sitting in this, that this is a challenge. Qualified people who are trained in the new algorithm and software, but notice that last phrase. Make sense of the results. If all you do is code, I have news for you. You will be replaced. I don't need you. I don't. I will replace you. Anytime you're doing a coding work, just coding work, I'll replace you. You will be replaced because the software will do a better job. What we can't do yet, and hopefully not for a very long time, is the ability for you to make sense and explain it back and make your judgment and make those subjective judgment and explain it back to the person who writes the check, who is your boss, as to why that is the right model. The software still cannot do that. Someday it might, but not today. Not today. When that happens, we'll all have universal basic income. If you don't know that, look it up, okay? But it's not going to happen tomorrow. It's not going to happen in the next 5 years. 20 years from now, it might. But today, if you can make sense and explain those, you're not going to get it, okay? And then the last part of this is more of a business challenge, enterprise level challenge, how to implement results. It's one thing to run model. It's one thing to find some interesting results. It's a totally different problem when we have to implement it in an organization, because now we'll have to deal with a lot of other challenges, like, for example, you're going to replace somebody's job. You got to deal with things that are very difficult, like change management. Those are very different things. But yes, analytics, to do analytics correctly, that needs to be done. Needs to be done. So we talk about V's of data. I have three. There are other V's as well, but these three V's are the most important V's that creates problem for us. The volume, most people understand the volume. This is a graph of how much data we are now talking about in the world. In 2020, we're at 40,000 exabytes. Okay, what that is, I can't fathom what that is, okay? Because you start with megabyte, then you go to gigabyte, then you go to terabyte, then you go to petabyte, then you go to some other byte, and then you go to zettabyte and exabyte. It's just byte. It's humongous. Let's just put it that way, okay? There is no other way to say it. But that's not where the real problem is. Volume is only one problem. It's also the variety and the velocity. And what do I mean by variety? Well, the variety is we now have data which are not just numbers. Some of you were in my text analytics workshop. We talked about most of the data today is being driven by social media, video data, audio data, text data. That variety creates a problem. And then there is a third issue, which is the velocity. The velocity is how quickly the data is coming to us. How quickly. It's one thing to have large data or different data. It's a totally different thing. Our entire algorithm has to change when I have to do analysis on the fly, when I'm getting data every 15 seconds from your household electricity meter, which is telling me how you're consuming electricity. Oh yeah, I drive a Tesla. Every second, Tesla generates about 1 gigabyte of data that's being sent back to Tesla. They're tracking everything I do, where I go, how I brake, how I move my car. When I put it on autopilot, if I brake, it figures out that yes, maybe their autopilot program needs to be redesigned. That's the velocity of the data. It's not just how much, but how quickly it's coming at you. Oh yeah, we have to have that too. So that's, those are some of the challenges that we deal with. So if you've never seen this, just to sort of put this into perspective, Typically, when we talk about big data, we are talking about mixed data, data that is both numeric as well as text and video. Typically, volume of data, most of us will say more than 10 terabytes, you are in a big data range. Typically, the flow of data is not static, it's rapid changes, it's coming at you very, very quickly, okay? Typical analysis methods are machine learning, data mining, deep learning methods. An objective is trying to figure out database product and services. What most of us have been trained in is this, and what we are migrating to is this world. This is where the world is going. That doesn't mean this is not important. Both coexist. Because remember what I said, you have to make sense of the results. When I run a convolution neural network with 150 layers of neurons in those networks, even I have no way to explain that. I can't explain it. Can't explain it. So I have to still have the ability, because in the world of business, I have to explain it. So I have to still have the ability to form hypotheses, ask questions, try to test it out. So they're going to go hand in hand. They're going to go hand in hand. Methods a little bit different. I said there is a fundamental tension between BI and analytics, and it's true. The data environment creates this tension, and I'll tell you why, okay? It creates this tension because of my friends in IT. I have lots of friends in IT, but they hate me sometimes because I give them too much trouble. I ask for too much stuff, okay? So they get mad at me. But so you have to think about, you know, the typical BI environment, what we have set up in most universities or most companies is basically a production environment. The load is predicted. SLA means service level agreement constraint. So SLA constrained, heavily governed standard tools. This is a steady state system. That's what has been set up. It's been set up for ad hoc reporting. It's been set up for producing monthly report and dashboarding and visualization, but static way. As soon as we go to the analytics side, it changes. It's exploratory, it's ad hoc, it's unpredictable. We like to do experiments, we like to change things and see what happens. Governance is a problem because we don't sometimes pay attention to that some data I may not be allowed to use because it comes from a different department. Oh yeah. If you work in a financial sector, you will know. Even if you have data on your customer, you cannot use it in certain cases. Depends, so you have to have those governance. And in this case, it's almost always we want a sandbox. We want to play using any tool that works. If it's Python, so be it. If it's R, so be it. If it's SAS, so be it. If it's Google TensorFlow, so be it. We don't care. Don't care. We're going to solve a problem. It's your problem from the IT side to figure this out. So notice that there is a fundamental tension between the two. But this problem is now being solved, and this is the popularity of what we call the data lake. The concept of data lake, if you have never been exposed to, this is the reason why data lake has become popular, because it allows us to do both. Allows us to do both. So what that means is we are going to set up, it doesn't have to be Hadoop, but some form of HDFS or MapReduce type of system where we feed the data in, and then we create two different environments, a BI environment, the BI environment, which is the steady state environment, and then we also create an analytics environment, which is a sandbox, and the sandbox means this is the play area. This is where data scientists and analytical folks play. That's because you got to give me that. If you don't give me that, you're not going to keep me in your company. But that's sort of the motivation behind how this is set up. I think in one of my workshops I mentioned this yesterday or day before yesterday. The problem in analytics is also this problem of what we call the iceberg principle. Okay? In an iceberg, if you look at the iceberg looks very pretty. Very pretty because you always see the top. That's 10% of the iceberg. 90% of this is below. You don't get to see it. What's my point? My point is 90% of the work in analytics and data science has nothing to do with modeling. It has everything to do with setting your data up correctly, cleaning your data properly, setting this up so that the data can be used. The hard work is below the waterline that you don't get to see. when you get to work, when you work for a company, you work as an analytics professional, chances are 80 to 90% of your work would be cleaning data, working with data. So learn SQL programming. SQL is not going to go away. Learn SQL programming, learn good database skills. Those will go a long way. Yes, you will need R and SAS and Python, but that comes later. Get the base right. Get the base right. Get the ability to use SQL to pull data, clean data, because chances are that's going to be around for a long time. Because you'll need it. You will need it. You know, my garage, I wish I had a toolbox that looks like this, okay? My garage, if I show you a picture of my garage, you'll throw up, because I got all kinds of tools that don't match and they look bad and they, you know, they don't fit, and I use whatever the hell closest to my hand that I get, okay? Wouldn't it be nice if software were like this, very nicely organized, they all play nicely with each other? Got news for you. In a company, when you go work for a company, you will not find this. This is what we would like to find, which is very nicely organized software that all talks to each other. What you will find is some legacy application that is a standalone. What you will find is some web application that doesn't talk to your legacy application. What you find is your databases. Some of these are old, 20 years ago, and somebody wrote some Visual Basic or C++ code, and that guy has passed away, and nobody knows how to change that code. It's a mess. It's a mess. In real world, that's exactly what it is. If I have to, the advantage of companies like Amazon and Google is they started only in 1995. They can set things up much better. If you look at any traditional company that has been in business for 20 years, 30 years, 40 years, they have 20 different IT systems. Probably 20 different types of software, maybe hundreds of spreadsheets that exist in different parts of the company that doesn't talk to each other. So yeah, we have a problem. Ideal world, we would like something like this. Ideal world would be an enterprise level software that talks seamlessly to our legacy system, that can do everything. In the real world, we don't have it. So what we do is we make do. We do the best we can. We don't quit. We do the best we can. So when needed, I use SAS. When needed, I use R. When needed, I use Python. When needed, I will use Google TensorFlow. I'll use Amazon Web Services. I will use whatever it is that I get. I will even use Microsoft Azure system. Why not? I need it, I will. Tool and technology is replaceable. Any tool, any technology that you get trained on is replaceable. It's going to go away. There'll be always new tools. You just have to be mentally ready to be able to absorb and learn as you go along. Learn as you go along. That's the best message I can give you. This is the good news part for you, okay? One of our challenges is keeping and finding the right people. The picture is not showing up very well with the lighting, but what it really means is, I have a name for this. I call it multiple personality disorder people. Okay? What businesses are looking for today in the analytic world is people who are like me. Okay? Because when they call me, they say, Dr. Chakraborty. Actually, they call me Dr. C because most people cannot pronounce my name, so they call me Dr. C. I say, Dr. C, I've got a great opportunity for a student of yours. I say, yeah, I'm listening. What is it? I say, well, I want a data scientist. Okay, we got it. What kind of skills do you need? Well, you know, Dr. C, we'd like them to be good with SQL so they can pull the data. And modeling, yes, we like them to know R and Python and SAS. And by the way, we want them to know statistical analysis. And I'm nodding my head. I'm saying yes, yes, yes. And then we'll say, but you know, we also need people who can talk. That means they can talk to an executives and explain what they have done. They can make good presentation, and they can be a good team player, and they can be a good project manager, and they can understand the domain of the business. I'm in a financial industry. They need to understand the financial terms and be able to talk in the language of the financial people. And oh, by the way, you only want to pay $50,000, and I hang up. I said, you're looking for me at $50,000, you're not going to get it. You're not going to get it, okay? But here's the problem. The problem is what's happening is the skill set that's being demanded from all of you who are going into the job market is really both sides of this, both sides of the brain. We really are asking, and this is why your life is going to be much more, in a way, much more difficult, but it's also challenging, and it's lucrative. If you can develop both sides of your brain, the communication side, the soft skill side, as well as the hard skill side, you are golden. That's what they'll pay for. I'll tell you what the average salary of the students of my program is. These are master's program students. And by the way, before you think it's all Americans, no. 90% of my students are foreigners. They come from India, they come from Vietnam, they come from China, they come from, unfortunately not from Mexico. I'm hoping that'll change. But most of them have an engineering or technology background. They have about 2 years of experience. They come to our program, and when they get out, the average salary is $82,000 US. That's the average salary, $82,000 US. They pay for this. They pay because the expectation is so high. You don't have to like it, but that's what it is. You have to develop both sides. You have to be able to tell a story, like the way I'm doing it. You also have to step back immediately and run a SQL code, run a R code, run a Python code, and run a model and explain it. There lies the problem. So you don't have to take my word for it. We published a paper recently, and we looked at 600,000 posting of jobs on LinkedIn for the last 3 years. And these are the skill set that are being mentioned in this. And I have highlighted wherever is more than 25%. And one of the first things you will notice is communication and interpersonal skills. Analytics, almost 70% of the jobs have it. Business analysts have 62%. Big data, if you're working in the infrastructure, still 45%. Data scientists, 50%. 50% of the jobs mention that as a skill set. Yes, there are other skills needed, but this is a published paper in Inform's journals on applied analytics. You can find it online, and you will see what skills are required. This is not based on a survey. This is based on text analytics of 600,000 plus job ads. Yep. So I said, you know, there's also this challenge of key challenges with leadership and other things from companies. This is a little bit high level, but we do need senior management support in terms of doing this correctly. One of the big challenges that I deal with when I go to companies, and I talk to many different companies over years, and the question is, how do I set up an analytics department? When I talk to the C-level, which is the chief executive level people, the questions that we often get asked is, okay, so Dr. C, you have looked at all this industry. Who do you think we should have? Should we manage analytics as a separate center of excellence? Should we build it within the company, in every department? If we do it every department, do we need a chief analytics officer? Do we need a chief data officer? Do we need a chief data science officer? Who owns analytics? And there is no right, wrong answer to this question. It depends on the enterprise. It depends on what that enterprise is capable of. I have seen both sides. I have seen separate center of excellence and also analytics as part of every department. Both have been successful. It just depends on what the nature of the enterprise is, what is the culture in that enterprise is, what kind of support structure exists within the IT environment of that company. All of those are the ones that result in this. And then last but not the least is this issue of improving the process, and this is where some of the change management principle comes in, because frankly, when we do good analytics project, that replaces people. That sometimes changes people's job requirement. And that creates a problem, because we have to be compassionate. We have to be able to understand how people are being affected. Because if I develop a system and the system changes your job, and if you don't buy into my process, chances are you're going to sabotage my system. And it happens. Happens. You have to pay attention to people. You have to pay attention to how you change people's life as we try and build all this. I'm going to switch gear, and in the next 15 minutes I will talk about OSU's program. So as I said, it's a journey. We started a long time ago over many different, we went through a lot of different iterations, and we came up with what we think is an appropriate model today. But let me take you through it, and then we'll wrap it up and ask for questions and comments. So, as Dr. Jose Luis pointed out, I'm from the business school, and there are two departments in the business schools that are intimately involved in developing all of the analytics and data science program. One department is the Department of Marketing, the department that I belong to, and the second department, I think Dr. Sharda was here before, is a couple of months ago, is MIS, which is Management Information System. So these are the two departments that have worked hand in hand over the years to develop the curriculum and the program that we have. So just to start a timeline, we started this in 2004. I told you, not yesterday, not a year ago, not 5 years ago, not 10 years ago. We started it since 2004. In 2004, we partnered with SAS. At that point, the only degree we had is MS in MIS. That was the degree. And so I partnered with SAS along with the MS and MIS department, creating this certificate called SAS and OSU Data Mining Certificate. What is that? Well, that's nothing but a set of 4 elective courses that taught people how to do data mining. MIS students were taking electives without any direction. They were taking an elective from here, an elective from there, elective from here. There was no direction. So we partnered with SAS saying, okay, you know, we will teach you data mining, we'll teach you data analytics, and if you take this 4-course sequence, you will actually get a SAS certificate. That's where we started. In 2004. Then over time, what happened is, so that was a certificate. Then we came up with a diploma for folks who are online, because we started getting demand for people who are working in the industry. They're saying, hey, we can't come to your campus. We want to do this online. Fine, so we started a diploma online called Graduate Certificate in Business Data Mining. Then we continuing on, about 2011, the MBA students started complaining that you guys are doing all this for technical students, people who understand technology and engineering. We are MBAs, but we want to learn analytics as well. So I said, okay, we'll do another certificate, because I can't teach them R and Python code. You cannot, you know, I can't teach. Some MBA students may be capable, but not everybody is. So for MBA students, we have to teach analytics using purely point-and-click interface, not coding-based interface. So we created a new certificate called SAS and OSU Marketing Analytics Certificate. That's for the MBAs. 2013, we started getting pressure from MBAs who have graduated and who are working online and said, we can't come back to campus, give us something online. So we started a diploma called Graduate Certificate in Marketing Analytics. Right? Eventually, and finally in 2015, so until this point is MS and MIS online and full-time. In 2015, we split the 2 degrees. It became MS in MIS with data science option and MS in business analytics. Okay? What was the difference? The difference was MS in MIS data science option was less of business oriented and more of data and programming oriented. MS in business analytics is, yes, there will be data and programming, but it's clearly rooted in the world of business. Continued like this. We started a healthcare analytics certificate in 2017. And starting this year, these two are coming back together. So the program is now going to be called MS in Business Analytics and Data Science. Data Science becomes an option within the business world. Because what we have realized is MS in MIS with data science without having business background doesn't work. It's that communication part and that ability to explain part that has to be there. So now these two are coming together. So the degree will be called from 2019 as MS in Business Analytics and Data Science. That's our history. I'm really proud of the students that have gone through our program and the things they have done. So I'm going to show you some bragging things. This is like my kids, so you know, we always show kids pictures. So these are my kids pictures, okay? You know, some of these, the tall guy, the bald-headed guy, is the CEO of SAS, the Chief Executive Officer of SAS, who is the what did I see? He is the 49th wealthiest person in the world. 49th wealthiest, $7.9 billion is his net worth. Okay, I'm not making this up. Look it up. Dr. Jim Goodnight. Those are the awards he's giving to. These are all my students. Okay, as I told you, we started this a long time ago. So some of these awards, whenever you see Dr. Goodnight, it's and there are other things that our students have done. We take students to conferences. We make them participate in competition, because it's a very, very important part of your development process, and that's what we do. So these are all of our students and others who have been to many, many different conferences with me and other faculty and presented papers. And this is last year's April, I chaired the SAS's Global Forum. This is about a 6,000 people conference, and yeah, that's me. You can't see very well. But what you are going to see is a ring of about 150 of my students who I took there. They're my students and alums who are all on the stage with me. So that was a very big moment for us, and we are very proud and having that ability. I show you that because I'm going to show you the statistics. These are the metrics that I live and die by. Okay? This year we'll go over 1,000 certificates. That's a huge. We have gone through about 955. The number of best paper awards my students have won is 27. 22 is number of awards in analytics competition. 76 scholarships and awards, and 325 papers. These are master students. Yes, most of our master students land up presenting and doing papers, and that's part of our program is for us to teach you how to do this. So that's and you know, that's sort of who we are. To give you a sense of the type of courses we go through is, you know, I won't go through the details, but what you will notice is that SAS, R, Python, Tableau, Google TensorFlow, and SQL is sprinkled throughout these courses. That we use all of them interchangeably. Yes, it's a hard program, and we go through, we give you options to create some specialties, so you can specialize in statistics, marketing analytics, and healthcare analytics, and other places, as I mentioned. So there are those available. We have a great corporate advisory board of companies. These companies work with us. They help us do our curriculum and do the meetings and give us feedback, and that's how we develop our program. Some of these companies you might know, some you may not, but FedEx, I'm sure you know FedEx, and SAS you probably heard. Comcast is one of the big giants in cable, and notice that they're not necessarily in Oklahoma. Comcast is in Philadelphia, SAS is in North Carolina, FedEx is in Memphis. They come to campus to hire our students. Okay. I want to talk about something that is very near and dear to my heart, because as good our program is, the program will not be right if the values are not correct. So we do a very strong emphasis on certain core values in the program. And the core values that we go by is integrity, which means doing the right thing when nobody is looking. Okay? Curiosity, which is asking questions. Accountability, that means being accountable for any action that you take or you do not take. If you see somebody cheating, you have to tell. Because non-action is you're accountable for not taking the action as well. Respect, not just to professors, but to your colleagues, to the other students, to the staff who work at the university. Respect has to go across the board. And then last but not the least is empathy. Empathy is being able to feel what I feel, walk in my shoes. That is the core value that we go by, and we emphasize this very heavily in our program, very, very heavily in our program. So just don't just so you think, it's all work and no play. I want you to understand, one of our motto is also we work hard and we play hard. These are all of our students who are, that's Indian dance. Some of our students who are doing a Diwali function that happens, and then there are a tailgating party and basketball party. We go to things like this very often. This is our Global Forum kickback party with all of our students. And this is Denver Broncos. For those of you who don't know, Denver Broncos is the team in Denver. So we are in their locker room. We are in their locker room and hosting a party for our students in that locker room. We do some fun exercises, things like boot camps and team building exercises, boat racing, all kinds of different things that we do to get you into sort of building some bonds and things like that. So it's not just work, but play as well. So, we have a lot of different things that I talked about. My hope is it will generate some interest in you, that you understand what we do as Oklahoma State. And as I said, one of my reasons for being here is to try and explore possibilities of doing things with UPAEP down the road, and we'll see where that goes. So with that, I think we're right about timing-wise, got about 10 minutes for Q&A, so I'm happy to take questions that you might have. So I don't know how you want to handle questions. Okay. Yep. I know I went through a lot, so you need to, but it's okay. If you don't ask questions, I'll feel very, very bad, so you have to ask questions. Okay. So come on. Anything you want to ask. You got to ask something. We're not going to go from here until you, for those of you who are in my training, I'm not going to let you go until I get a chance to answer at least one question. So I have to have a question.
Here is one.
All right, good. Thank you, thank you.
I have a question. It's more like curiosity for me. Why the biggest part of the students are from India?
Good question. Yes, so the question is, why are the biggest part of the students from India? And partly is because our program is very well known in India. And part of the reason that happened maybe because I'm an Indian. I go to India once a year, so people know me there. Part of the reason also the MIS students that we have. Information technology is a very big deal in India. and the engineering and the information technology students, they know about our program and they apply to the program. And the last part is the Indian students generally have a fairly good English. The communication is a little bit easier. I have to, and we have communication seminar that we take students through. Even with Indian students, they don't communicate the way the Americans do, but those may be the reason, because they have the IT background and the technology background, and they know us, and they feel comfortable using English, and that's my guess. But it's a good question, good question. But I'd like to change it. I'd like to see some Mexican students there. Yes, please.
I'm studying the master in data science.
Mm-hmm.
Is there any possibility to do a double degree or something like that?
So this is something we are exploring, so that's something that we would explore. But university is like how would I put it? A very big ship, a humongous ship, like those cruise liners, like a 7-story Norwegian cruise line. That ship moves very slowly. You can't change the direction very quickly. So we are talking about doing some joint program. It might take a while, and you might have graduated. But what I'm going to suggest for you is what you could do. What you could do is, today most of the courses are available online. You can find so much material online. If you have the curiosity and the ability, you can teach yourself on your own. At this point, if you want to start something at Oklahoma State, we don't have a system in place, but we have online program on graduate certificate in business data mining that's taken by students all over US and outside of US. So you could look into that possibility, that if you could do potentially an online program, but the full data mining, data science program is a 2-year program, and that's hard to do while you are already in a data science program here. So, but there may be some possibilities down the road. Okay.
Another question. What book did you recommend that is your best book for analytics?
Oh, I don't have a best book. I've got some of the, so I've given you some non-technical books, and I've given you some data science friendly books, okay? So, but there are plenty of others, plenty of others. Okay.
Hi, Dr. C.
Yes.
I want to specialize in financial risk management, and I want to know if you can give me an advice, or how is the industry there in the United States or in globally, if you have some experience.
Yeah, and it's a great question. Financial industry absorbs about 25% of our graduates. 25% of our graduates go into big banks. Banks like, so some of my major employers of our students are Citibank, JP Morgan Chase, Capital One, Barclays Bank. These are major banks that take many of our students. So the banks need analysts, and they need analysts who are have data science training, but they work mostly in the risk management side. Okay, so if you want to go into that area, you need to understand what banks talk about risk. I'm sure you have a finance department here. Take a course in finance department understanding what is the risk, what do we mean by financial risk, what are the risk models, what are some of the what we call stress test models that banks go through. Those are all models. They're all data science friendly models, but you have to understand the terminologies first. So we have our students in the analytics program, those who go into the financial analytics, they take an accounting course and a finance course, MBA level accounting and an MBA level finance course, so they can understand the industry, because it's hard to get into the industry without having the terms and the concepts in your mind correctly. So I would suggest that that's something that you look into, but it's a great field. As I said, 25% of our students go into the financial industry.
Okay, thanks.
Good.
¿Una pregunta más?
Aye, one more.
Well, I'm a finance student in fact, he is. And I think his question was more about if we are already in finance world and are familiar to finance terms, what could be an advice you could give us to get into that data analytics path to get a better chance in finance?
Okay, so if you are already in the finance program, then you are already in good shape, because you already understand the finance. What you need to figure out is to understand data access, data management, which is what I said with SQL programming and databases, and then data science friendly stuff like R and Python and modeling. So the best way to do this would be for you to create, I don't know whether within the undergraduate program is possible to do all this. You may have to do what we have in Oklahoma State is what we call a 4+1 program. So if you are a 4-year student in an undergraduate studies, we will take you in as a finance major. You'll come into the analytics program, and you graduate at the end of 5 years with the analytics degree along with the finance degree in your undergraduate degree. So something like that would probably work the best for you guys here in terms of partnering and finding some. And even if you don't go through a master's degree, if you go through SQL programming, maybe Python, and get some modeling experience, that will help you go, even if you don't want to do a full degree. And I understand degree may be difficult, it adds more time, it's more costly, all of those issues, but at least those, you got to understand SQL, some database, you got to understand either Python or R or SAS, one of those, and you got to understand some modeling.
Bueno, pues entonces creo que nada más nos resta darle un buen aplauso al doctor Chakraborty.
Thank you very much.
Faculty of Business Intelligence gives another recognition to Dr. Chakraborty for his valuable contribution.
No. I'm happy to be here.
In this lecture, and for the experiences shared with all of us during these 3 days of his visit at UPAEP. Thank you so much.
Thank you very much. Thank you. This is very pretty. Thank you very much. Thank you. Okay, I'm going to try and keep this and not break it. So, anything else? Good? Be curious.